He's cleared quite a bit of ground out here since last time I've been here, and even done some more construction on buildings. But we're here to look at the fence, and this is what he's got going on. You can see the posts he's got in the ground. These would be the 2 7/8 pipe, where we're going to have 3 runs going in between these, and I'm just going to start walking up the line. Left a super service truck up the hill up here, just to give you an idea. I think he said he's doing about 600 feet of fence altogether. And you would, I know, like in the portion that I'm walking right now, a lot of people would say, man, you're doing an awful heavy duty fence. Why would you need it to be such solid welded steel? But when I get up here around the turn, I'll show you. He's got a pond down here, and the road he's built above the pond, right down here, you can see this is where a fence like this kind of comes into be. You know, he's probably thinking of his wife or his boy driving down here on a weekend or whatever, and the risk of somebody in a vehicle sliding off into this pond. It's going to be a nice pond. I'm sure this will fill up nice. But I'm sure that's what he's thinking as far as, you know, if you put up some barbed wire here, it's not going to stop a vehicle from rolling, you know, and ending up upside down in that pond. What we're putting in here would stop a vehicle from sliding off this hill and going in the pond. So what I'm going to do, there's a few things I want to measure and look at. We're just kind of doing an evaluation right here. Back here at the shop, I know from being out there that pipe is indeed 5.5 outside diameter. So the jig that I want to lay on it, that the material that I'm going to get that fits it as close as I can fit it, is going to be a piece of 6-inch pipe. And I've brought a piece in and marked it out so I can show you some idea what my jig's going to look like. When I cut this out of 6-inch pipe, the idea is going to be that I'll be able to lay this piece on my 6-inch pipe, and these holes right here should be the right diameter. If I shouldn't have to make a mark when I'm out there on site. If I just clamp this on the pipe where I want it and take my torch and cut through these 3 holes, I'm hoping I come out with the right layout for everything to work really well. What I've got right here, I think this is a piece of an old lolly column for a basement, actually. But this was something I found that was exactly 3 inches outside diameter. So I coped it to fit this pipe and used it to make these marks. So the actual holes I'm putting in my jig are going to be 3-inch. And when I burn through those, the holes that I'll be putting in the pipe would actually be 3-inch. And I think that should be fine for the 2 7/8 pipe to go into and weld it up. And, you know, there may be some places you got to use an end grinder or a burr bit or something. But hopefully we don't have to do a lot of that. And that's something I can probably adjust on a little bit out in the field. You know, I'll be putting pipes in, or at least trying them as I go. And if I'm getting them too loose, I'll have to do something. If I'm getting them too tight, I'll have to do something. But I think the key right now, I would want to err on the side of making my hole too small. And I think for a 2 7/8 pipe to go in, 3 inches is kind of tight. I would really like to have 3 1/8. If you had a 1/8 inch gap all the way around, that would be great. But you don't need a 1/8 gap. As long as the pipe goes in it, you're all right. So I would say lean towards the small side. And if you get out there and they're too small, it's going to be easy to make them bigger. If you make too big a hole in your jig, it's hard to fill that back in. So we don't want to go that way. But at least for today, I want to get this cut out. So that's what's up. Those areas of my jig there where there's a radius, I'm going to be cutting that with a hand torch. Also the holes, obviously, burn those out with a hand torch. What I got here is a double-aught tip with my oxygen on 40 psi, acetylene's on 7. Get the holes cut, get the radiuses cut there on the end, and then I switch over to the track machine for the long straight cuts. I'm pointing that torch towards the center of the pipe, so my cut is kind of going to be 90 degrees from the wall of the pipe, where I'm cutting it straight off. Get it lined up and let her eat. In order to switch it to the other side, I let this arm go way out, and that creates a problem with balance. There's a fix for that, a counterbalance. So I end up grabbing a piece of tubing to put on the other side. Compensates for the torch sitting way out there like that, and the weight of the torch and the hose being so far from the machine. Found me a medicine bottle that's exactly 2 7/8. Use that to check my holes. That's the size of my pipe. That medicine bottle's real handy to check it with. Something plastic and light. It's perfectly round and just the right size. It should go in the hole and kind of waller around. Bought a couple cheap clamps from Harbor Freight. Taking the grinder cutting wheel to them right off the bat. That's why I got the cheap ones. To cut one finger off, right flush, cut the other one off where it fit an angle iron clip. I've got a test piece of pipe up there. So one side is welded directly to the jig. The other side of the clamp's got an angle iron clip that fits the pipe. Got the super service truck out on the scene. Just going to get a chance to see how this goes with this jig. Got a mark that represents the center of the top. Clamp the jig on there and just reach through and cut out the holes. The thing that I noticed about the oxyacetylene, takes you a minute there to heat the pipe up because that pipe is quite thick. You blow through it with the oxyacetylene and you're cutting around the hole and it works fine, but in order for that pipe to go in there and that hole to be correct, you have to keep the torch flame running in line with the way that pipe is going to go in there. What that does is, when you're cutting the portion of the hole there at the sides, you're pointing your flame sort of on the radius of the pipe. And the heat doesn't really want to transfer correctly. It would transfer a lot better if you could point towards the center of the pipe. But if you did that, your hole actually wouldn't allow the pipe to go in it, because you'd be leaving material on the inside that needed cut away. Oxyacetylene torch worked, but a couple things I noticed was it seemed slow, and it seemed like the oxyacetylene flame around that radius made it even slower, where I really had to slow down to keep it cutting. Here I want you to notice how I've got this string set up. If you look the way I've got it twisted at each post, I've actually got the string meeting itself at the center of the pipe, and that's important for what I'm doing. Because what I want to do is simulate the way that the one pipe is coming into the post and the other pipe's going out. This is a job like this is a combination between marking the pipe and eyeballing it. Because you only want to follow the ground so much. I've got a mark there at my height, but because of the way the ground lays, that makes, if I go where the line is, it's really high. And I got a mark here, and if I go where the line is, it's really low. So some of this is just sort of looking at your string, looking at your measurements, and splitting the difference. So what do we got going on here? Well, I got the idea that if the oxyacetylene was going to be kind of slow because of the way that flame was, what if I had an electric flame? What if I had a plasma cutter? So I got out the old Commander 300 diesel, because if I'm going to run a plasma cutter, I'm going to need some power. I got 2 air compressors and the Arc Captain Cut 55 Pro plasma cutter. Had this old girl for 24 years. She's a beast. And it will run a plasma and 2 compressors. No problem. That Arc Captain Cut 55 Pro, pretty much the instant I pull the trigger, I've blasted through that pipe. And when I get around to that radius area, that electric flame doesn't give a damn if it's on a radius or not. It just goes through. The plasma cutting turned out to be something on this job that saved me a lot of time. One thing I noticed was that it was hard to follow my pattern with the plasma cutter. The way the tip was, it just didn't want to, it wanted to make a hole that was too small. So it turned out that my pattern actually worked better to clamp on there and use the pattern to make a soapstone mark. And then I just followed the soapstone mark with the plasma torch and cut them out that way, and it worked great. And this really made things a lot faster and easier. And as here you can see that I just did a fast video where I went through there first and made the soapstone marks with the jig, and then came back behind and made the cuts with the plasma. And as a side note, I actually also have the SIMDER Cut 50. I got out the SIMDER and I tried it. And I cut one hole with it and I put it away. The SIMDER for the money is a good machine. It does, you know, it's a plasma cutter that works. It's a handsome machine, but it just doesn't have the power that this Arc Captain 55's got. And I had already cut a bunch of the holes with the Arc Captain, so when I got out the SIMDER and cut a hole, I was like, well, nope, she just ain't got the smoke. Went right back to cutting with the Arc Captain, and that for me was the way to go on it. Been laying the blaze to this pipe with that Arc Captain Cut 55 plasma, and it's going real good. One of the things that's been annoying me is this. I don't use this. I forget what you call the 220 plug that comes on a lot of these. Okay, this is an N650P. N650. N6-50. So these are great. I mean, but I don't use it. I use a NEMA 1450. And on all my stuff that I've said before, on all my stuff that's runs off 110 or 220, I just want this on there. I don't even want this because I use 10 gauge and 12 gauge cords with this plug. I use them for 220 and 110. That way I can use the cord for both. And I just do it with an adapter. So anyway, what I was saying about this annoying me, I looked through my tools and I have a spare 110 plug end male. This is what I'm going to put on the back of the Arc Captain. I'm just going to eliminate this. And the first thing I want to do is chop this off. Well, I chop it off and with wires I'm used to dealing with, you would have black, white, and green. Sometimes a red, but always a green ground. Well, these wires speak Chinese. I've got brown, blue, and yellow. And the yellow has a green stripe. So there's no white, there's no black, and there's no green like I'm used to. I know if it was white, black, and green, I would say 100% the green's the ground. And that's the one I need to know which one it is. The other two could be either way, as long as you got the ground right. The other two, either way, it's fine. So I only need to know about one of these wires. I got out my meter, and I've got it set on continuity. Okay, so using that, I just want to touch this ground. And then I'll touch these wires. I'll touch the blue one, red one, or brown one, the yellow one. This yellow wire is the ground. So that yellow wire's got to be connected to that. The other two, just hook them up, and that'll get rid of this big plug I'm dragging around. Everything rigged up on the trailer, I realized that I lost that pin. I like to have those keeper pins in those things, especially around here on these hills. But I'm a long way from the store. What I got here is a 1/8 inch 7018 welding rod. The vise that's on the bumper of the super service truck, a 3/4 inch, 1/2 inch drive impact socket, and a good set of Irwin slip joint pliers. Eyeball her up here and give her a whirl. That way I feel a whole lot better about that hitch staying latched. Got that Arc Captain Cut 55 Pro out here in the mud. This little machine has put in some work on this job. What a bunch of cutting. Run off the generator the entire time, no problems there. I tried just for fun running the plasma cutter and both air compressors off the Trailblazer 302, and what I noticed was it would run. I started out, it was plasma cutting fine. One compressor kicked on and it continued to work. When the other compressor kicked on, the plasma cutter wouldn't run. And I knew it would reach a point with that Trailblazer where the power making system just wouldn't keep up with the draw, and that's where I found it. So I think even running the plasma cutter and one compressor is really, it's a lot for the Trailblazer. That Commander 300 handled it just fine. So we get started welding and figuring out how we want to go about welding these things. And the first thing I tried was the Arc Captain MiG 145 with 030 Arc Captain flux core wire. And I was kind of thinking with the small diameter wire, the small machine, and running less heat, maybe it would fill those gaps and fight that magnetism because of the lower heat and the small diameter wire. And what I found was that the wire did good. The machine did good. It seemed like I could go faster if I had bigger wire. But getting started out, I guess I started out with the small stuff first and the small machine first, and it did really well. It welded good. It ran off the generator just fine, and I didn't have any problems at all, other than the contact tips. I was going through contact tips pretty fast, and recently did a video where I did an upgrade on the guns for flux core for the 145 and the 200, and modified them to accept some bigger contact tips. I haven't got a chance to run a bunch of flux core on those that I modified yet. Looking forward to getting a chance to do that. But you can see when you got welding like this to do, This is really a lot more than you should ask one of these machines to even do. You know, these are not, these machines are not meant to be welding with them one weld right after the other at high heat all day long. You know, these machines are marketed more for the hobby welder, the mechanic at home. You know, it's to be understood that, yeah, I'm using them as a professional and I'm beating the tar out of them and they're taking it. But it's to be understood that you're going to find things like, oh, I think the contact tips are burning up fast. It's light duty, you know. It is lighter duty stuff. But as an Art Captain affiliate and a YouTuber, I'm going to keep beating the hell out of these machines, and I'll always find a weak point. And the case with welding really hot, hard, and fast like I'm doing here with that little Art Captain 145, you know, I would say the weak point that I found was it just got those contact tips so hot. I would wipe the spatter off the contact tip every once in a while, and one time I wiped it off and I looked at it and it was bent. You know, I got it so hot that the copper actually bent. So I was really putting her to the test, and that machine did quite well. So the next thing after, next step up would be to use the Art Captain MiG 200 like I'm doing here. And in this case, I'm running the 035 Art Captain Flux core. So I've went up 5 thousandths in the wire diameter with the same type of wire and a bigger machine. I'm running this Art Captain MiG 200 off of the Lincoln Commander 300 on the 220 volt current, and running more voltage, of course, than I would be running with the MiG 145 and the 030. And really enjoyed welding with it too. It did very well. It seemed like the 035 was able to weld faster than the 030. And that kind of made me want to keep going with diameter. Now right here, you see all that fire. This is the magnetism that's in this pipe, and this is what it does to you. When you get on one that's really heavily magnetized, half of the welding that you're trying to put in there gets thrown back in your face. The polarity of the magnetism will just, it'll throw it right out of there. And that's why I made this clip right here, where I actually slowed it down. This is at half speed. And I want you to see just the amount of sparks and fire that's being thrown out by the magnetism of that pipe. And I circled that area. All of that area that I circled, you should be able to see, is just being bombarded by molten metal that's being thrown out of the puddle instead of going in. And I tell you, over 20 years in the oil field, I heard every trick in the book to fight that magnetism. You know, stick weld it with this rod, that rod, switch your polarity, preheat it, demagnetize it. I've never seen anything that was economical time-wise that really worked. The best thing you can do is just fight a pass around it, and it'll weld fine from there. And here we got the old brick nose dually out, and got the Commander 300 on the flatbed of the old brick nose dually. And we're running the Commander 300 as a welding machine on this trip. We've been using it as a generator pretty much, but what I've got here is one of my LN25 Lincoln wire feeders, and this has 045 Hobart Fab Shield 21B. So we're stepping up another 10 thousandths in wire diameter. And I noticed once again, the larger diameter wire, you know, you might think filling these gaps around this pipe, running more heat would be to a negative, but it's not. It turned out that it seemed like the bigger diameter, the better. Having a little feeding issue here actually got her stuck, man. It happens every once in a while, and that's one of the things about wire feed welding is, you know, it saves a lot of time. In a lot of cases, it really is faster sometimes in certain jobs, but a wire feeder is quite a gizmo, and you know, the more complicated something is, you're more likely to have some problems. I got rid of that bird nest, got everything rerouted and wired back through the gun, and always take the contact tip off when I'm doing that. Cut that wire off and then put a new contact tip on there and went back to it. Now, here in the end, I end up with 068. This is a different wire feeder. Got the one of my other LN25s. I lost track of how many of them things I got. I got 4 or 5 LN25 wire feeders, but this one's set up with 068 diameter Lincoln NR211. And what I'm doing right here, I wanted to show, I'm using a screwdriver to center that pipe in the hole. If you don't do that and you let the pipe just lay in the bottom, you have a bigger gap at the top than you have at the bottom, which is undesirable. Wanted the gap even all the way around. So what I'm showing here is how I just slide that screwdriver underneath the pipe, jam it in the gap, and then when it's centered up in the hole the way I want it, then it's ready to tack. And obviously, you know, we've tried a lot of different flux core wire. We've tried different types and different diameters. The bigger diameter turned out to be better. It was better all the way around. The larger diameter did a better job filling the gap around the pipe in the hole. And the larger, the more heat, the higher voltage I was able to run with the bigger wire, it seemed to help with the magnetism. The more heat, it was better. Now I remember what was going on here. Must have had some corrosion. There were several times I was pulling my trigger and the wire wasn't coming out. And so I squeezed the trigger and I reached over and I touched the contact there at the machine, and then the wire started feeding again. And I noticed as I was goofing with it that I would squeeze the trigger and I would touch it and then it would work. So I disconnected it and I looked at everything and I felt for a broken wire. The wire didn't feel broken, so I reconnected it, put the connector back on, and from there it didn't have any trouble. So I think it was just something that every once in a while something needs wiggled or jiggled, and that was the case here. Getting my wire speed set right, and once everything was set up good, I think I ended up all the way up at like 25 volts on the Commander 300, and running the 068 Lincoln wire. And then this is just a fast clip of me running her up a line, you know, getting her done, getting some welding work done. Got everything tacked where it needed to be and laid the smoke to it. Getting back here to the shop, been an absolute pleasure being able to run the old Commander 300. Haven't done much welding with it for a while. Used a lot of different flux core wire and did a lot of experimenting on this magnetized pipe and We're getting her zipped together. I think I'm at a point where I've got enough video shot to pretty much get the gist of what's going to go on here. I'm going to put a video together with what I've got and get it uploaded. If there's any more really to it, I'll probably do another video, but more or less showing the hole cutting, showing a little bit about the welding, the method that we used. I think that's pretty much going to be it. I mean, we might be cutting off some of the posts that are a little high or whatever. The welding is nothing to look at, because with that magnetized pipe, what I'm basically doing is welding one pass around it as fast and dirty as I can do. And just to explain the situation with that, when I was talking to my buddy that I'm doing this for, there was a point where we had he mentioned and wanted to discuss the welding a little bit. And what he was kind of wanting to say was, he was wanting to ask me, like, do we really have to even weld all the way around it? Could we just tack it? You absolutely could. The construction method that we used, where we cut the holes and we cut the small pipes several inches longer than the inside diameter of the posts and put those pipes in there, if you didn't even tack them, they would serve the purpose. They would stop something from pushing through there. Now, as a welder, and I think any welder, you're going to want to at least weld all the way around it. And if this was a job where the customer was saying, spare no expense, I want it right, well, I'd run 3 passes on that. I'd run 3 passes and make it look nice. And you could with 3 passes. And the reason that you could is because when you're dealing with this dirty magnetic pipe, once you've run a bead all the way around, just the one pass, that magnetic flux or whatever, the polarity of the magnetism that gives you so much trouble, one pass is pretty much all it takes to break it down. And from there, it'll behave. It'll weld like any other pipe almost. It does want to undercut a little bit more because it's high tensile steel. But it's unfortunate to some extent that we're fighting the one pass in there, and we're probably not going to put any more weld on there. I'll talk to my buddy once I get a pass around everything and see if he wants to do any more. But you got to understand, from the customer's point of view, he's paying you to weld this stuff. He doesn't want you to weld it more than it needs to hold. And I've learned over the years, especially on stuff like this, as a young welder, I would see where a weld was ugly on a handrail or something, and I'd be like, oh, look at that, that's awful. Yeah, a welder's gonna do that, especially a young welder. Who else? 99% of the people are going to drive down that fence line and say, oh, what a nice fence, and never even get to the point of looking at the welds. Getting up there and looking at the ripples. It ain't going to happen. People don't care. And as a welder, yeah, you want to weld everything, make it gorgeous, but on the economic side of things and on the realistic side of things, can you go and weld on this fence for 3 weeks, and charge that person for all that time? Not if you want a happy customer. Like I said, the construction method we used basically makes it overkill if you even weld all the way around it like we're doing. Now, I think just fighting one pass and sealing up around it like I'm doing is the right thing to do. Right now, I'm not buffing the slag off. I'm not going back and fixing porosity. I'm just zipping around it. Maybe when I'm done, I'll go up the fence line with a cordless grinder, hit it with a wire brush. Maybe I won't. I'll talk to my buddy. He's got a lot of work up there and a lot of people that come up there and help him. He may have days where he's got a laborer up there that's working on one of the buildings, and they get to a point that's all they can do for the day, and he needs to keep that laborer there for a full day. He might tell that laborer, hey, take this cordless grinder with a wire brush I got at Harbor Freight and go down through there and hit that with a wire brush. Well, that would be way more economical than paying a welder who's got all his equipment there and expense, and he's burning fuel. He's standing there burning fuel and trying to get welding done. It would be way more economical to send that laborer up through there and wire brush that stuff. So you got to be understanding with people. And like I said, we're probably just going to leave it with the one pass around this stuff. And that's probably going to be it. And it's probably overkill, really. Like I said, with the construction method we used, it doesn't need welded any more than that. But anyway, I'm going to put a video together with it. And if there's a lot more on the fence or something that I want to share later, I'll do another video. But I want to thank y'all for watching. And remember, like I always say, learn how to work with what you got, and that way you always have everything you need. Hey y'all, CB here in the break room at NBS Welding, coming to you with another merch video. Want to look at the merchandise, show you what we got. You can help support the channel by buying items. We got the NBS Welding t-shirts, got the NBS Welding on the chest on the front, got the great big NBS Welding here on the back, got the American flag on the sleeve. $25 plus shipping. Send Tina an email if you'd be interested in buying a t-shirt. $25 plus shipping. Send Tina an email, nbswelding@aol.com. The stickers. Got the small size stickers, $3. Medium sticker, $5. The big bumper stickers, $10. The coins, .999 fine silver. If you'd be interested in investing in the silver coin, got NBS Welding name and phone number on the front. Got the bull logo on the back. $50. $50 for the coins. Also with the coins, we've got the plastic case. Keeps the silver nice. Keeps it from getting fingerprinted and all that scratched up. The NBS Welding cups. Got the NBS Welding cups with the bull logo, and it says less yakking, more tacking. Got the QR code on the top. You can scan that. It'll take you to the NBS Welding YouTube channel. $27 for a cup. And I've had somebody said that I should sign the cups. I'm not doing that yet. I don't know if you want me to do that or not. But if you want a cup and you want me to sign it, I'll take a Sharpie and I'll sign it. I'll write whatever you want on there. Let us know. Send us an email. nbswelding@aol.com. Email Tina. And I'm not wearing an NBS shirt. I'm wearing a Kretschmer Excavating shirt. These are my buddies up in northeastern PA. If you need excavation work done in Wayne County, northeastern PA area, get a hold of my guy Cody up there. He can dig it. All right. I want to thank y'all for watching the NBS Welding YouTube channel. I appreciate all the support. Please continue to support, like, subscribe to videos, comment on the videos. If you don't have a comment, just go to the comment section, hit any letter, number, the period, whatever. The algorithm doesn't know the difference. Just, you know, that helps support the channel. It helps get the videos out there. And y'all learn how to work with what you got. That way you always have everything you need.